Now we are going to be solving simple differential equations. A differential equation is just an equation that has a derivative in it. So look at this equation right here. It's an equation, there's a derivative, f prime of x. That's all it is. It can be first derivative, second derivative, etc. When I say solve the differential equation, all that means is I want to get back to f of x. So how do I get from f prime of x to f of x? I'm going to take the antiderivative. Now this is an equation, so really what I'm going to do is take the antiderivative of both sides. So that antiderivative is an operation that you're performing, and your variable of integration on both sides is really a dx. So this is really what you're doing. I'm taking the antiderivative both sides. Anything I do to one side, I can do to the other side. So this will give me back to the original, which is going to be f of x. And I can just use the power rule here. This is going to be 2x cubed plus x squared over 2 minus 5x plus c. So this is called your general solution. Now notice though in the problem, I give you an initial condition. So there's lots of curves that have this equation because that plus c can be anything, but I'm giving you a particular point on the graph, so I want the one exact equation. So we're going to plug this point in and find that plus c that is this particular graph with this point. So 0 is x, y is 2, so you can plug in your x value, and we can see easily that c will be 2. So my solution is actually this. And this is called my particular solution. So when I ask you to solve a differential equation, all you're doing is trying to get back to f of x. Let's try one more example. So this time, you have the second derivative. So again, when I say solve it, I want to get all the way back to f of x, so we'll just have to do the process 2 times. So step 1 is I need to get to the first derivative. So I'm going to do the antiderivative of this. So this is going to be 5 sine of x minus 2 cosine of x plus c. Now, before going on, find that plus c first. But notice you are given 2 pieces of information. This is your first derivative, so you need to use the information about the first derivative. It's saying that the first derivative at 0 is equal to 4. So the y value is 4 when I plug in 0 here. Okay, so you have 4 equals 0 minus 2 plus c. So c is going to be 6. So here is my first derivative. So there's my c. Now go ahead and do the process again to get back to f of x. So I'm going to take the antiderivative again. So negative 5 cosine of x minus 2 sine of x plus 6x. Now you will have another constant. Now, you can call it c if you want. Just keep in mind these are not the same numbers. In the book they will call it a different letter d, but it's fine if you call it c. Now for this one, I will use this point. So when I plug in 0 for x, and you will get out to 3 for y, let's plug in the values. You should end up with c in this case is actually 8. So your final solution is going to be this.